Hi dear students and developers, welcome to the Refinitiv developer community. My name is Jonathan Legrand and I'm here to start a new series of videos going through our articles in detail, line by line and step by step. They will be of low intensity and slower than videos made in the past that were 5-minute short introductions of articles. This series will help you to learn to code and introduce yourself to the world of finance and the world of developers. They will not only go through the coding aspect of things, but also the theory applied in each one of them. The videos I will make will tend to be academically inclined, but a wide range of them are coming up. So without further ado, let's get to it. All right, then the best place to start is going to be our developer community portal, on which we'll be able to find the article that we're going to investigate today. The article in question is Estimating Monthly GDP via the Expenditure-Approach. You can just go on this search bar and type that in. Once you find it, you can click on the article in question, and we'll have a quick look today at the theory underlining the article in question, as well as the very start of how one may use Python to go through the coding of this and how we can import our libraries. The second part is going to go more in depth into the article itself. There is already a video that's a very short start for a 5-minute introduction to the whole article that just goes through the entire thing for you to have a feel, a flavor of the whole thing before you go full-fledged into the tutorials. All right, to start with then, I would encourage anyone to, instead of trying to install Python on your own and go out of your way to on your machine, to actually just use our Refinitiv codebook. To get it, you can just access it with your browser. I'm using Google Chrome, but you can use anything else. I've seen it used with Internet Explorer or Firefox, and that means you can access it on your phone. Obviously, because I'm recording, I thought it better to use my computer. There, you will be able to log into your Refinitiv icon web access by clicking on Sign In. Due to my automatic login, I wanted to just show you how that would look like, and you'll be shown with a window where you might be able to put in your user ID and your password to log in. All right. Once you're through that, you'll be put through to your Refinitiv workspace. Let me put it here. Okay, and on there you will have access to everything exactly as per your workspace if you were to download the application itself. And you can access CodeBook straight from this environment. Let me just make things a bit bigger so that it fits the window a bit better. And there you can access CodeBook by going on your app library at the top left, or I think there's always a shortcut there for you. Then click and search for CodeBook. It will come up right here, where you'll be able to open it. CodeBook is a Python environment that you'll be able to use on your browser like this in order to go through your code and access our Refinitiv APIs with relative ease. Today, we're going to be using Datastream DSWS to collect our data, and I'll show you step by step how to do so. But first, I thought it better to go through the navigation panel on CodeBook. You can see on the left here. If you're familiar with Jupyter Notebook, you'll be very familiar with this whole environment. But I wanted to go through the whole process from the ground up. Okay, so the first thing I'm going to do is create a folder and name it appropriately for our investigation. All right, and double clicking on this will get us inside the folder where we'll be able to create a new Python file. Once your Python file is created, you can rename it on the left in the navigation panel. And then click on Control B to get rid of the navigation panel on the left. And now we can just concentrate on what we're working on. In CodeBook, you can use a mixture of code, markdown, or just raw editing. If you have raw, this is literally just text and it doesn't do anything. If you have code, that will be your Python code. But first I want to go through markdown, which will allow you to create some text that is somewhat interactive. I have some already there, so let me just copy and paste it. It's straight from the article that you may find on the developer portal that I've shown just before. And here you may be able to see that you can use hashtag to create headers, and you can use a mixture of things such as square brackets and round brackets for links, and some mathematical equations with dollar signs. There's a great variety of things you can do related to LaTeX coding. If you're interested in that, you can look into it further online. All right, pressing on Shift Enter will run this cell. Now, as I said, this is a markdown cell, so all it does is that it shows you information with a bit more information than just text. And here I've created my header talking about estimating monthly USA GDP figures via expenditure-approach and the Holt-Winters model. All right, let's go through what all of this means. We're going to try and use the expenditure approach of GDP calculation, which uses C plus I plus G plus X minus M. C being consumption, I being investment, G being government spending, and X minus M being net exports. The issue that is addressed in this investigation is that the United States GDP figures released by the Bureau of Economic Analysis in US Department of Commerce are only released on a quarterly basis, whereas you may want to use higher frequency data to gather more insights into what you may want to do in terms of investment. The issue that we are addressing here is that the Bureau of Economic Analysis in US Department of Commerce only releases GDP figures on a quarterly basis. All of the summands of the GDP calculation here are released by this department on a quarterly basis apart from consumption. And we're going to be using that higher frequency release of data of consumption to try and estimate monthly GDP data. One may try to just interpolate the estimation of monthly GDP, but there are several reasons why one may try to use our method instead. First of all, if you just try to interpolate such information, you will have to wait for the new quarterly GDP release to come up. So, for example, in January, at the end of January, you might want to know what the GDP was for that month in January, but you'll have to wait until March in order to be able to interpolate backwards in time what that January GDP was. Here we'll be able to do it in near real time. Not only that, but interpolation, or even just using a simple regression model or OLS model, will render you a straight line analysis that may not take into account the higher frequency data that we have with consumption right here. And that's what we're going to be doing using the Holt-Winters model. Now, if you want to know more about the Holt-Winters model, there are some really great articles I found online going through not only the Holt-Winters model itself in terms of its mathematics, if I can scroll down and show you, there it is, but also in terms of the coding. It goes through the Holt-Winters model in Python. And instead of going through it, I just put a link to the Medium article right there for you. So without further ado, let's get to try and find out the development tools and resources that we're going to use. First of all, we're going to be using Refinitiv Datastream, DSWS, to access our data from Refinitiv. This is the largest database that I know of for macroeconomic indicators and just metrics in general. Our Python environment is going to be Python 3.7 in this specific instance, and we're going to be using Python packages ranging from Datastream DSWS, NumPy, Pandas, stats models, all the way to Matplotlib. All right, let's get to the nitty-gritty part of things with one last markdown before we start coding, importing our libraries. The first library that I'm going to be importing is the native Python library called Platform. This library has a function called Python version that allows you to have a look at which Python version you're using, as well as whether it's a 64 or 32-bit version you're using. Going forward, we're going to be using Datastream DSWS. Now, to do so, you will need to enter your username and password. And to do so, I will import Datastream DSWS as DSWS, just to shorten it, and create a password and a username from text files found alongside my code. To put text files in this fashion alongside my code, I can just create them and put them in this location right here. The only reason I am doing this is because I don't want to be showing my username and password and sharing it when making these videos or when sharing my code. You may choose to just put your own username and password right here. So for example, if your username is John, there you go. That's what it is. But I'm going to be going through this method. To do so, I'm just going to create a text file and name it the same as what I said it would be on there. Right, there you go. Now in there, I can write my username and do the same for the password. All right, here it is. I've added my password and username here on the left alongside my code so that it would run together. Pressing Ctrl B, I can get rid of this navigation panel and go back to my code. If we go through what I've done here, I have used the Python native function called open to just try and open a text file that is in the same directory, which is to say the same path, the same address as where my code is running from. I'm looking for a text file with this name. The .txt is the extension that shows I'm using for a text file, and the R here just says to the open function that I just want to read the text file in question. Now I'm going to be using DSWS's Datastream function in order to identify myself to the system. I'm going to be using the username and password arguments and enter in the string, which is again another Python native function that translates whatever is in brackets as a string, which is just a string of characters as opposed to it being a function or anything as such. Using the object that I have created up there, you see I've created this object from the open function, and I need the .read function of that object in order to return the actual name in itself. If I can show you very quickly, you can do the same for your password, and you will be creating an object whereby you will be identified to the system data stream. I thought it best to show you how one may use Datastream to collect data from our database. And first of all, in order to do so, you might want to use a ds.getData function and go through the Datastream online platform to figure out which ticker to use. All right, going swiftly on to our article, you may scroll down, and at some point I speak about the data points that we're going to use within Datastream. And if you click on any of them, it will send you over to the Datastream portal where you can put your username and password to identify yourself. This will then send you to the homepage where you can scroll down and click on series, which will get you to your navigator. Here you can type anything such as USA population, and it will return you a series of information where you can find the symbol in question. So here, for example, the mnemonic I'm looking for is this one. Using as an example the USPER comb, we can see that this is the mnemonic for something else. Let's have a look at which one that is. There we go. It's the United States personal outlays and consumption. So we're going to be using consumption data that you can find here is monthly data as opposed to quarterly to then improve the accuracy of our monthly estimation of GDP data. Okay, so looking at our consumption data, we will be using the argument ticker to specify the mnemonic of the data stream object that we're looking for. We're going to be using the argument field to find out which field we're looking for exactly. X is the default, so you might actually not want to put it in, but not only the default, but X stands for the default field for your ticker in question. So here, for example, it's just going to be US dollars. And the start can be spelled in this way, as well as the end, and your frequency here is going to be M because it's in month. Don't forget you can use the end argument, but by default it's just today. All right, running all of our code up to now, I wanted to show you how it would work by going on run at the top. And then we have created an object called data that includes a pandas data frame of all of our data. Pressing Shift Enter, I can run my code, and we have a look at our data this far. You can see that it comes in monthly, but on the 15th of the month. And then we can use this information and manipulate it as we want to continue our investigation. We're going to import some native Python libraries such as datetime, dateutil, both of which allow us to manipulate time, such as, for example, if I was to say -1 and it would do -1 day, such as yesterday, and warnings if we want to create our own warnings throughout this code. After running this, we may then want to import some Python libraries that are not native. These in question are already pre-installed in CodeBook. Statistics allow us to do some statistics in Python. NumPy is a very good mathematical library for Python. Stats models allow us to do quite an awful lot of mathematical modeling, but specifically we're going to be using our exponential smoothing and Holt-Winters models in this article. SymPy is a scientific library, and we're going to be importing specifically stats as well from it. The following loop is just there to show you the version of the libraries that we're using. So here we're going from NumPy 1.18 all the way to SciPy 1.4. Moving swiftly onwards, I wanted to make a specific and separate cell for pandas because it's going to be one of the most important libraries we're going to be using. Pandas allow us to manipulate data frames, which, as I've explained, are returned by the Datastream library. Next, we're going to be using matplotlib. Matplotlib is a Python library that allows us to plot some graphs that are static. We might want to use interactive graphs with Python libraries such as Plotly, and I will show you how to do so in subsequent articles and videos. All right, this is the end of the very start of our tutorial, going through our estimation of USA GDP using the consumption data. I will be going through the original setup of functions that we're going to create ourselves. And this far, we've only gone through very few Python functions, such as a Python native ones and ones related to the imported libraries. Here, we've used the set option to display the maximum number of columns for our dataset so that we can see all the columns in all the datasets, so the tables that we're going to be looking at. We've used the .version function that allows you to have a look at the version of everything we're looking at. And we had a very quick example of what a for loop is. Here, for example, we are looking at for I and j within the list of NumPy, StatsModel, and SciPy. We're going to print, which is to say display on the screen, the string the followed by the I, which is to say our library in question, then the string library imported in this code is version, followed by the .version function of the library that we've imported. But we're going to go into more detail and create our own functions instead of using ones that were out of packages, libraries, or native. Don't hesitate to have a look at our developer community website, where you can find all of these articles and more right here in recent articles. There are a great variety of them written by myself and my colleagues, and they're all just as interesting as each other. All right, I'll see you in part 2.